Marine ecosystems are some of the most diverse on the planet, with millions of interactions on many different levels. It follows then that a slight shift in equilibrium can have massive repercussions. For example, a blue-green algae organism is microscopic, but plays an extremely significant role in marine systems. Commonly mistaken as algae, it is in fact a type of cyanobacteria. Present in many marine environments, it plays a crucial role in the primary production of organic molecules, also known as the carbon cycle. Through nitrogen fixation, cyanobacteria also contributes to ecosystems. Nitrogen is an essential compound for a large amount of both aquatic and terrestrial organisms. And although 80% of the Earth's atmosphere is nitrogen gas, most of these are unable to use it unless it is converted into compounds such as ammonia. Recently, however, as a result of many factors, blue-green algae has begun to grow excessively in certain areas. This algal blooming is a severe problem, leading to decreased biodiversity and poor water quality, particularly within the northern region of Morton Bay and surrounding areas such as Bribie Island and Deception Bay. Overfishing and pollution discharge into coastal waters, along with natural iron discharge from groundwater, and rising climates are observed to be correlated with blooms. Sewage discharge leads to eutrophication, the process whereby an excess level of nutrients, mainly nitrogen and phosphorus, in marine environments enables rapid growth and hence colonies to reach maximum capacity very quickly. Here at Queensland University, ongoing research is being conducted into the possible causes and most effective management strategies to control current blooms and ultimately prevent their occurrence in the future.
Here we're talking about ferrous iron, we're talking about iron. Iron is a key nutrient for the limbia. In fact, it has been hypothesized that ferrous iron or bioavailable iron is a controlling factor or triggering factor for the limbia bloom, and that's why we're looking at groundwater, because in dissolved form, iron exists probably more in the groundwater system rather than in the surface water.
Over time, these blooms begin to decay. This process consumes oxygen, increasing biochemical oxygen demand, and literally suffocating organisms in the surrounding environment. As primary producers and consumers die out, biodiversity is severely decreased. Decaying also releases a series of toxins which cause skin irritation, inflammation, and respiratory problems.
I'd never swim here because there's heaps of algae and it's really itchy, and there's also dead fish everywhere, and then the algae is really slippery as well, so it's really dangerous.
In addition, it smothers seagrass, decreasing its biomass, and inhibits mangrove seedling growth. The endangered green turtle, dugongs, and many fish species rely on seagrass for grazing and cover, and mangroves for spawning. Research has shown, since the bloom in 2002, a 10-year low measurement of dugong herd size, the highest annual dugong mortality rate, and the lowest percentage of female turtles preparing for breeding. Increasing incidence of lesions on marine turtles in Morton Bay has also occurred with the presence of limbaya on seagrass on the eastern banks.
Sea turtles in the Morton Bay area would probably generally eat seagrasses, amongst other things, because they're reasonably omnivorous, but they mainly eat seagrass, which could be a big problem if you do have an algae bloom, which would reduce the amount of seagrass in the area, forcing them to probably move further afield to feed, which could be a bit of a problem for them.
The underlying problem, however, is a general lack of in-depth knowledge as to what causes need to be addressed in order to curb the incidence of blooms. Another proposed strategy is the introduction of a biocontrol, for example, the sea hare, Stylacelius, which grazes on blue-green algae. The effects of blue-green algae in Morton Bay hence not only decrease biodiversity and organism abundance, but severely reduces water quality, proving it to be not only an environmental hazard, but a serious biological issue. So all in all, despite the occurrence of Limbaya majuscula being crucial to marine ecosystems and having positive effects, human involvement, as well as the development of favourable growing conditions, has led to its deterioration into a severe problem. The effects of blue-green algae in Morton Bay hence not only decrease biodiversity and organism abundance, but severely reduce water quality, proving it to be an environmental hazard.